In this topic, before we start off, I will ask all my students to be prepared and to have all the required instruments for constructions, because at the end of the topic, you will need to do a constructions regarding to transformations. But before we get to the transformations, we shall start with the first part of the topic, which is matrices. Therefore, students, we are in our lesson today, we are discussing Form 4 mathematics. We are discussing Form 4 mathematics. And our topic of discussion is matrices and transformation. Matrices and transformation. Matrices and transformation. Dear students, we have learned some bits of matrices in Form 3 work, because that is the foundation of matrices and transformation. The part for transformation, students, is covered in Book 2, Form 2 work. That is where we introduce the aspects on transformation. And we shall list down the transformation that we shall need to cover in this topic. We will be discussing, or rather at the end of this topic, the student should be able to discuss the following transformations. And this transformation, as I've indicated to you, were covered in Form 2. Right from Form 2 topic 6 up to topic 8, we start with the first 3 transformations. So the students, do you know what are they? Yes, the 3 initial or basic transformation covered in Form 2 is reflection. Number 2, we have rotation. Number 3, with enlargement. Those are covered in first 3. Then we have 4 with translation that we cover under vectors with translation. And the other 2 which we are going to add to this list are what we'll cover in this topic. We call it shear, and then we shall cover what we call a stretch. These are the transformations that we shall be able to cover when we link the information to matrices. Therefore, students, as we start our discussion today in the topic matrices and transformation, we shall need to review the Form 2 work on transformation. And number 2, we shall need to review the Form 3 work on matrices. However, we shall not be able to discuss all of them, all the details as covered in those 2 topics, but we shall pick the main areas that are key to what we need to discuss in matrices and transformation. And so the first thing, students, under matrices, I want us to review something we call operation on matrices. So we shall start with the first part on matrices. First part on matrices, we will discuss what we call the operation on matrices. Operation on matrices. That is the first item that we shall need to look at before we get to transformation. When we discuss about operation, what do we refer to, students? What do we refer to under the operation on matrices? Good. We discuss 2 main parts. What we discuss here, we have what we call addition and subtraction. Addition and subtraction of matrices. That is 1. Number 2, students. Good. We shall have to discuss multiplication. Multiplication of matrices. Multiplication of matrices. Therefore, in our lesson, under matrices and transformation, we are going to discuss 1, the operation on matrices. of which we will cover addition and subtraction of matrices. And number 2, we'll discuss multiplication of matrices. Number 2, students, under matrices in Form 4, as a student, you'll be required to understand the basic concept on determinant of a matrix. Determinant of a matrix. Determinant of a matrix. And specifically, we will concentrate on what we call the 2x2 matrices, students. Remember, we have order of matrices where we give the order of a matrix based on the number of rows against the number of columns. Based on the number of rows against the number of columns. What are rows then? What are rows? This is a row. This is a row. Horizontal. They are called rows. So this is row number 1 and row number 2. When we talk of columns, students, columns are vertical. The vertical arrangement of elements in a matrix constitute to what we call a column. Therefore, columns are vertical, while rows are horizontal. And when we identify the number of rows in a matrix against the number of columns in a matrix, that gives us what we call the order of a matrix. And that's why we are saying in this part, we will discuss a matrix of order 2 by 2. 2 by 2. And lastly, you will need to review on what you call the inverse of a 2 by 2 matrix. An inverse of a 2 by 2 matrix. These are the key areas that will give us the foundation to build on to what we call matrices and transformation. As I've identified to you, this is 2 in 1. There is an aspect of matrices and there is an aspect of transformation. Matrices covered in Form 3, transformations covered in Form 2, plus the additional 2 that we will cover in Form 4. Therefore, you cannot study the whole topic as one unless you break it into 2 to analyze what is under matrices and 2 to analyze what is under transformation. Then now we combine the 2 to form matrices under transformation. Good. So let's start off to discuss these areas as we've highlighted them on our board. One is to note that when you're carrying out operation on matrices, and specifically when we are discussing about addition and subtraction of matrices, addition and subtraction of matrices, we insist that students, you cannot be able to add any 2 matrices without considering their order. What does that mean? It means very simple, that for you to add or subtract matrices, you need to identify the order of a matrix. You need to identify the order of a matrix. And therefore, as our keynote here is that to add or subtract 2 or more matrices, they must be of the same order. They must be of the same order. For you to add or subtract matrices, students, they must be of the same order. Meaning, we cannot have a matrix of order 2 by 2 being added to a matrix of order 3 by 3. Equally, we cannot have a matrix of order 2 by 1 being added to a matrix of order 2 by 3. Why? Because the number of rows in those matrices versus the number of columns do not tally. So make sure when you want to carry out addition of matrices, at whichever level you may be, ensure you are able to separate between the matrices to ensure you only deal with those matrices that are of the same order. For example, if we are given this, number one, given that A is a matrix 3, 1, negative 4, 6. B is a matrix 0, 8, negative 2, negative 3. And that C is a matrix A plus B. Find the matrix C. Find the matrix C. Students, we've been given a question that given A is 3, 1, negative 4, 6, B is a matrix of elements 0, 8, negative 2, negative 3, and that C is a matrix A plus B. Find matrix C. Find matrix C. First thing, which order is matrix A, students? Which order is matrix A, students? Yes, these are matrix of order 2 by 2. To those who do not remember what it means that this matrix has how many rows? 1, 2. It has 2 rows, that is 2. How many columns, students? It has 1, 2 columns. And so we say is a matrix of order 2 by 2. Same thing to matrix B. How many columns? How many rows? 1, 2. 2 rows. How many columns, students? 1, 2. 2 columns. Therefore, the matrix B is of order 2 by 2. Matrix A is order 2 by 2. Therefore, it qualifies the condition for addition of matrices, where we are saying for you to add or subtract 2 matrices, they must be of the same order. And that is true that they are all of order 2 by 2. So we can be able to add. And in that case, students, we say these matrices are compatible. They are compatible. So let's work it out, students, to get what is the sum of these 2 matrices and eventually identify what is matrix C. Our solution, C is A plus B. C is A plus B. Therefore, what is A? 3, 1, negative 4, 6. We add B, 0, 8, negative 2, negative 3. And addition or subtraction is based on the numbers or elements at each position. This is the first position. So they will be added in that order. So we shall have 3 plus 0 and 1 plus 8. Then negative 4 plus negative 2, 6 plus negative 3. So what is the sum, students? 3 plus 0 is 3. 1 plus 8 is 9. Negative 4 plus negative 2, students, is negative 6. And 3 plus minus 3 is 3. Therefore, our matrix C, students, is 3, 9, negative 6, 3. So we shall have obtained our value for matrix C. We have now matrix C in place. Good. Example 2, number 2. If P is a matrix 1, 3, 8, 4, 6, 2, 0, 3, 9. P is that, and Q is 5, 6, 7, 1, 3 minus 2, 4, 0, 3. 4, 0, 3. Find the value of part A, P minus Q. P minus Q. We find the value for the matrix P minus Q. Students, again, I will refer you to our initial starting point of our lesson when we said that you only add or subtract matrices that are of the same order. Who will help us identify the order of matrix P, students? Who will help us identify the order of matrix P? Yes, the order of matrix P is 3 by 3. Why 3 by 3? It has 3 rows. This is the first row, the second row, and the third row. How many columns, students? 3. The first column, second column, and third column. Why are they columns? We said columns refer to the vertical arrangement of elements in a matrix. The vertical arrangement of elements in a matrix is referred to as a column, and the horizontal arrangement of elements is referred to as a row. Therefore, this is a 3 by 3 matrix. Equally, this is a 3 by 3 matrix. So we will add or work it out by subtraction of the two matrices. We'll say P is 1, 3, 8, 4, 6, 2, 0, 3, 9. We minus Q, which is 5, 6, 7, 1, 3, negative 2, 4, 0, 3. 4, 0, 3. This gives us, let's work it out the same way we did addition. 1 will be subtracted together with 5. So it is 1 minus 5, that is negative 4. 3 minus 6, that is negative 3. 8 minus 7, that is 1. Then 4 minus 1, students, that is 3. 6 minus 3, that is 3. 2 minus 2. 2 minus 2. That gives us 4. 0 minus 4. Negative 4. 3 minus 0, students, 3. And 9 minus 3 gives us 6. Gives us 6. Therefore, our matrix P less Q is negative 4, negative 3, 1, 3, 3, 4, negative 4, 3, 6. And you'll realize, students, that this is the same order just as the matrix P and Q. So we will not have a situation whereby you have a matrix of order 3 by 3 resulting into a matrix of a different order when you apply addition or subtraction. They will remain to be the same order. Part B. What if now we are asked to find the value for Q Q, now plus P. Q plus P. The first one was minus. Now we have Q plus P. So we'll take Q. Q is 5, 1, 4, 6, 3, 0, 7, negative 2, 3. We add P is 1, 3, 8, 4, 6, 2, 0, 3, 9. 0, 3, 9. Let's add 5 plus 1. 5 plus 1, that is 6. 6 plus 3 is 9. 7 plus 8 is 15. 1 plus 4 is 5. 3 plus 6 is 9. Negative 2 plus 2 is 0. 4 plus 0 is 4. 0 plus 3 is 3. And 3 plus 9 is 12. So the sum of those matrices is 6, 9, 15, 5, 9, 0, 4, 3, 12. 4, 3, 12. Item number 2 that students we also need to remember is what we call multiplication of matrices. Under multiplication of matrices, we first need to do what we call scalar multiplication. Scalar multiplication. We have scalar multiplication. Scalar multiplication of matrices. Scalar multiplication of matrices. Scalar multiplication of matrices. What is a scalar, students? What is a scalar of a matrix? Yes, a scalar is a quantity that multiplies a matrix. If I have a quantity like a matrix like P, and I multiply it by a quantity like a number 2, so it becomes 2P. Therefore, 2 is called the scalar of P. A quantity or a number that multiplies a matrix is what you are calling a scalar in this case. And so we have scalar multiplication of matrices. So if you have a scalar and a matrix, the scalar is distributed in each of the elements that form that particular matrix. What I mean is, if you have given a scalar quantity, I'm a multiplier of quantity of a vector of a matrix in this case, the scalar is replaced and multiplied by each element that form the matrix, by each element that form the matrix. For example, if we have a matrix, if we're given a matrix M, which is A, B, C, and D, to obtain 2M, for which 2 here is our scalar and M is our matrix. To obtain 2M, it simply means you take 2 into A, B, C, and D. So we spread out 2 is replaced by substituting it with what you have in the bracket. So 2 by A, 2A, 2 by B, 2B, 2 by C, 2C, 2 by D, 2D. That becomes our result out of applying the scalar to that particular matrix that we have. We get this more by looking at a practical example of such kinds of cases where a scalar matrix is applied. Example. Number 1, students, given that A is a matrix 3, 5, 1, 2, B is a matrix negative 2, 6, 4, 0, and that matrix C is 2B minus 3C. That is 3B. Find C. Given that A is 3, 5, 1, 2, B is negative 2, 6, 4, and 0, we are asked to find C, and the condition for C is that C is 2B less 3A. Sorry for this, 3A. Then to obtain this matrix, we are saying we will replace in the value of 2 and the matrix B and multiply. So our C will be twice into, what is B? Negative 2, 6, 4, 0, plus, sorry, it's minus, less 3A. 3 into A, 3, 5, 1, 2. Open up this. 2 times negative 2 is negative 4, students. 2 times 6, that is 12. 2 times 4, that is 8. 2 times 0, that is 0. Minus 3 times 3, students, is 9. 3 times 5 is 15. 3 times 1 is 3. 3 times 2 is 6. Let's work it out together. Minus 14, minus 4 minus 9. Minus 4 minus 9. What's the answer? Well, the answer is negative 13. 12 minus 15, negative 3. 8 minus 3, it's 5. 0 minus 6, students, is negative 6. Therefore, our matrix C is negative 13, negative 3, 5, and negative 6. That is called scalar multiplication of matrices together with addition and subtraction of matrices. Once we've been able to understand what is scalar multiplication, what is addition and subtraction of matrices, students, the final aspect on operation is what we call multiplication of matrices. Multiplication of matrices. When you talk of multiplication, the result of multiplying 2 or more numbers is called a product. The result of multiplying 2 or more numbers is called the product. The product is simply the answer or the result of multiplying 2 or more numbers. When you're talking about addition, the result is called the sum. When we discuss subtraction, the result is called the difference. What about division? Good, it is called the quotient. So the result of dividing 2 or more numbers is called the quotient. The result of adding 2 or more numbers is called sum. The result of subtracting two or more numbers is called the difference, and the result of multiplying two or more number students is what we call the product. Therefore, under multiplication, the language will be find the product. Find the product, meaning multiply those two or those three matrices that you've been given. There is a condition, students, that we have to be very keen before you get to multiply any matrix. And the condition is not as we've presented it under addition. Because under addition, we said that for you to add two or more matrices, they must be of the same order. But in multiplication, students, it is not the same. What is required is you look at the number of columns in the first matrix against the number of rows in the second matrix. Because the matrices could be different in terms of their order, but they are compatible in multiplication. Why? Because you find the number of columns in the first matrix and the number of rows in the second matrix correspond. So you look at the number of rows. Therefore, it is good, before you look at even multiplication, remind yourself, do you know what are rows? Do you know what are columns? Because that is what will guide you to identify whether two matrices are compatible by multiplication or they are not. So under multiplication, what do we say? We'll use this, our NB, to multiply two or more matrices, Number one, condition number one, they must not be of the same order. They must not be of the same order. They might not be of the same order, but the number of columns, in the first matrix, and the number of rows in the second matrix must be the same. Must be the same. That is the first thing that you will have to identify. That yes, they will not be of the same order, but we are telling you that these matrices are compatible. So what do you look at? Look at the number of columns in the first matrix and compare it with the number of rows in the second matrix. And that is why we say in multiplication, when we say take A times B, you have to strictly take A times B. You cannot reverse and say B times A, because sometimes when you reverse and they were not of the same order, they become incompatible. So identify what is the first matrix as per the question, and identify what is the second matrix as per the question. Then be able to tell whether the two matrices are compatible or they are not. Number two, you multiply matrices based on the logic or the rule of rows and columns. So matrices are multiplied. Sorry, not matrices, but let's say elements in a matrix or elements of a matrix are multiplied. Elements of a matrix are multiplied on the basis of row by column. Row by column. Row for the first matrix and column for the second matrix. It's important to remember that the row will be from the first matrix and the column will be from the second matrix. That is how we will work out multiplication of matrices in our lesson today under operation on matrices. Let's have an example to discuss this procedure that we've highlighted. students. As example, we are told if T is a matrix 1, 4, 3, 6, R is a matrix 2, 8, 4, 5. 2, 8, 4, 5. And the matrix M is a matrix 8, 3. 8, 3. Find part A. T R. Find T R. Find the product of the matrix T by the matrix R. Find the product of the matrix T by the matrix R. Yes. Where do we start from, our students? Where do you start from? Good. We have to identify whether T and R are compatible. Therefore, the next question is, student, is T and R compatible? Yes, T and R are compatible because they are of the same order. They are of the same order, and the order is 2 by 2. If they satisfy that condition, students, they now be able to proceed and do the multiplication. So we'll now be able to proceed to do the multiplication, but now we shall have T is 1, 4, 3, 6. Multiply this one by 2, 8, 4, 5. So let's start. Row by column. Multiplication is done based on the principle of, in the first matrix, pick the row against the column. So how will it work? 1 times 2, then 4 times 4. So we obtain the sum, 4 times 4. Then come again, 1 times 8, 1 multiplied by 8, add 4 multiplied by 5, 4 multiplied by 5. 3 multiplied by 2, add 6 multiplied by 4, 6 multiplied by 4. 3 multiplied by 8, 3 multiplied by 8, plus 6 multiplied by 5, 6 multiplied by 5. So this will be 1 times 2 is 2, 4 times 4 is 16. So 16 plus 2 is 18. 1 times 8 is 8, 4 times 5 is 20. The sum is 28. 3 times 2 is 6, 4 times 6 is 24. The sum is 30. 3 times 8 is 24. 6 times 5 is 30. The sum is 54. Therefore, our matrix TR is 18, 28, 30, 54. That is our product of TR, students. And if you get that now, you ensure you enclose the matrix in bracket so that it now forms the adhere to the rule of writing matrices, the rule of multiplying matrices. Now, number 2, we have to look at now the matrix R against the matrix M. Remember, the matrix R, M is of order 2 by 1. And the matrix R is of order 2 by 2. So we will be asked to find the product of the matrix R, M. R times M. R times M. So we'll write R is 2, 8, 4, 5. We multiply by M, which is 8, 3. Multiply by 8, which is 8, 3. Let's look at the order. Order 2 by 2. Order 2 by 1. What did we say? We said for the two matrices to be compatible by multiplication, students, they must be able to comply to the following rule. That one, if they are not of the same order, then the number of columns in the first matrix, and the number of columns in the first matrix here is 2, must be the same as the number of rows in the second matrix. In the second matrix is 2. Therefore, they are compatible because they are giving us the same value. And the result matrix will be of order 2 by 1. The resulting matrix will be of order 2 by 1. So let's proceed to do our multiplication. This will be 2 times 8 plus 8 times 3. Then 4 times 8 plus 5 times 3. 2 times 8, that is 16. 8 times 3 is 24. The sum, 40. 4 times 8, 32. 5 times 3, 15. The sum, 47. Therefore, the product of R and M is of the nature 2 by 1, which is 40 and 47. And we shall have multiplied the matrices in that case for order 2 by 2 against the matrix of order 2 by 1. And that forms the first part of what we said, the operation on matrices. So on this aspect, students, I want to give you 2 questions for you to try so that when we move to the next aspect, you will have clearly understood what is done under the operation on matrices, addition, subtraction, scalar multiplication, and the general multiplication of matrices. So this is your practice question. This is your practice question. The practice question is number 1. Given that the matrix A is 1, -3, 4, -2, matrix A, and B is a matrix, and B is a matrix 5, 0, -7, 3. Find part A. Find part A. 2A plus B. 2A plus B. B with the matrix B minus a half A. B minus a half A. B minus a half A. And then number C, you will work out A times B. A times B. And question 2 on that part, if X is a matrix, if X is 1, 7, if X is 1, 7, and Y is -1, 3, -2, -2, find the matrix YX. Find the matrix YX. Those 2 questions will help you, students, look at what we have discussed under first part on operation on matrices. On operation on matrices. Before we conclude, students, we will need to look at the last aspect that we highlighted, which is determinant of a 2 by 2 matrix. Determinant of a 2 by 2 matrix. Determinant of a 2 by 2 matrix. Who will try to explain what is the determinant of a matrix? What is the determinant of a matrix? Yes, the determinant of a matrix is the difference in the product of elements in the leading diagonal and the product of elements in the other diagonal. That tells you that a matrix has elements arranged in diagonals. A matrix has elements arranged in diagonals. So if you are given a matrix A, B, C, and D, these elements are in a diagonal form. Look at element A and D. They are in one diagonal. Element C and B, they are in another diagonal. How do we call this diagonal? We call it the leading diagonal. The leading or the main diagonal. What about the other? This one? Yes, this one is called the other diagonal. The other diagonal. So we have the leading diagonal and the other diagonal. Determinant of any matrix. Determinant of any matrix that is 2 by 2 is take the product of elements in the leading diagonal. You subtract the product of elements in the other diagonal. The product of elements in the other diagonal. That is what we call the determinant. So we can take one example on the determinant aspect. An example on how to get the determinant. You're told to find the determinant of a matrix T, which is 1873. 1873. Find the determinant of a matrix which is 1873. So how will we proceed, students? How shall we proceed from this question? It's quite simple. What are the elements in the leading diagonal? What are the elements in the leading diagonal? It is 1 and 3. Therefore, our determinant will be equal to 1 times 3. We minus 7 times 8. This gives us 3 minus 56, which is negative 53. Negative 53. So that is what we have under the introduction of matrices and transformation. And to review what we've discussed, students, we've analyzed 3 things. The first thing in our topic today under matrices and transformation was to identify what are the basic transformation. We've listed down the basic transformations, which we associated them to what we covered in Form 2, and they are deflection, rotation, enlargement, translation. And then this topic gives us 2 more transformation, what we call the shear and the stretch, that we shall discuss in our next lesson. We've also identified that this matrix topic is also based on what is covered in matrices in Form 3. And under that, we've identified 3 things that we need to cover. We need to cover the operation on matrices, addition, subtraction, and multiplication. And number 2, we need to look at what we call determinant of a matrix and the inverse. And we've conclusively discussed what is the addition and subtraction of a matrix, what we have under the scalar multiplication and the multiplication of matrices, and we've discussed about the determinant of a matrix. In our next lesson, students, we will discuss more about inverse of matrices and eventually discuss about transformation. How do we obtain the image given an object, whether it is done by a matrix of transformation or it is done directly as related to various transformations we covered in Form 2. So until next time, when we meet in our next lesson, I have been your teacher, Mr. Ndenga, Elphas. Thank you. See you next time.